Okay, so you guys have seen the three ways that we can build up a static charge or an imbalance of electrons. You guys have seen friction, which is with the balloon. You've seen conduction, which is using the Van de Graaff generator. And finally, this is our last one, which is charging by induction. Induction is a new word, a word we haven't seen in here, but we're going to see it reoccur a couple of times over the course of the next few months. But basically, an imbalance of electrons can be created by coming close to but not touching a charged object. Where conduction was you touch something directly and you'll become charged. This is when you become like indirectly charged by coming close to something but not touching it. So here we go. An imbalance of electrons can be created by, we'll say coming close to but not touching a charged object. And we're going to use this weird thing called an electroscope. And we have a little picture up here to show you how this works. And then I made one out of this really light foil. If you'll see, there's a flask, and then in it I have a bent paper clip. This is super ghetto, this thing right here. However, you can buy these, they're expensive. And I just made this with like a bent paper clip and this little thin piece of foil. This works better than any one I've ever bought before. So hopefully we should be in pretty good shape with that. I'm going to take it, I'm just going to set it right here. We're going to see if we can charge that sucker up through induction. Now, in order to understand what's going to happen, right now, this is our electroscope. Our electroscope looks like this. Now, what you need to do is draw this. You don't even need to draw the flask. What you need to do is have two little leaves or two little pieces of foil drawn. They can just be like two lines. And then you need to have a top of it sticking out like that. You know what it could look like? It could look like a stick figure with no arms. That'll work for you. Okay, stick figure with no arms. And then have those legs hanging kind of straight down. Okay, maybe bent a little bit. Not like that. We're going to draw it like this. If you want to put a flask around it, feel free. The flask is just used as an insulator, which we'll be talking about in the next lab activity this year. Okay, this electroscope right here is discharged. In other words, it's neutral. If this electroscope is neutral, what can you tell me, bless you, about the protons and electrons in it? If it doesn't have a charge, if it's neutral, what can you tell me about the protons and electrons? Mr. Ward, what are you thinking?
That they're even.
They're even. So let's draw some protons and electrons. Let's draw some positives and negatives around it. I'm going to put a positive there and a negative there. And then I'm going to kind of alternate to show that we got positives and negatives all over the place. Protons and electrons in our atoms. See how they're kind of evenly spaced around it? Now really, if we were to draw it, we'd be drawing millions of these things. But we're just going to draw a few. So this is discharged. It's neutral. Okay, we got protons, we got electrons filling up the whole thing. Now, check it out. What we're going to do is we're going to bring by a charged object. I'm probably going to use one of those pieces of plastic. Can I see if we can grab one? Actually, we want to start getting one charged up. That would be good. Efficient use of time here. What we're going to do is I'm going to bring by a big charged piece of plastic. So go ahead and draw like a big piece of plastic, like the green thing that you guys were using yesterday. We're going to bring by something that's super duper negative from using friction with a piece of wool and stuff like that. Now, this is strange, so you're going to have to watch really, really carefully. When we bring this charged object close by, and I'm curious to see how many hands I get in the air. When I bring this negatively charged object close by, do these electrons like that or not like that? You can raise your hand and tell me. Are these electrons going to be attracted to that, or are these electrons going to be repelled by that? Arquip, what are you thinking?
Repelled.
Yeah, they're going to be repelled because they're like charges. So what will happen is these electrons that you see will run down or try to get away from that thing. They'll actually bounce through the structure and wind up in the two leaves, so you're going to wind up with electrons down at the bottom. Now, if all the electrons rush down to the bottom of these leaves, what charge do the bottoms of the leaves now have? If those electrons rush down to the bottom of the leaves, all of a sudden it was neutral, but now the electrons all rush down to the bottom. What charge does it have?
Negative.
Negative. And if they are negative, then the leaves don't like that. And the leaves will then split apart, like that. And it's going to look like this. So what we're going to do is we're going to take that good and charged, I'm thinking. Hopefully I won't ground it then when I touch it. And you're going to take a quick peek at those leaves. Now this is really hard to see and sometimes it doesn't work. If you're sitting here, stay seated. If you're everywhere, everyone else, come on over. And let's watch our two leaves. Probably want to get these quizzes out. I'm going to hand these over. Oh. Pass this for a second. Thank you. All right, watch the leaves. Let's see if we can get them to move. Here we go. Watch carefully, 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 carefully. Do they move?
Tiny bit.
Whoa.
Oh, there.
How many of you can see it? I'm causing the electrons. I'm not touching it. I'm causing the electrons to rush down to the bottom because they don't like to be near this. And when those electrons rush down to the bottom, the leaves go, and then we're good to go. Now, I know you're not like, wow, that's amazing. However, it's the same reason why lightning works, and that will be the next topic that we talk about. Cool, you have quizzes waiting for you, or at least kind of waiting for you. Get back to your seats. Close up your journals. And go for it. Good luck. It's not a difficult one. I think you should be in good shape.